Well, let's jump right in. A couple of quick things actually before we jump into the session. What I'd like to do over here is obviously discuss what are microservices, moving into why Docker, all right, what is Docker and why should we consider using Docker? My apologies. And also, let's talk about what is Kubernetes and bring the whole thing together in a discussion where I like to throw in a little bit of DevOps principles and a little bit of um, um, continuous integration, continuous deployment as well in that presentation. So a lot of good things coming up for you. So this will be a mixture of presentation slash discussion. I do hope to reserve some time at the end for questions, scenarios you'd like to discuss, whatever works for you. So to get us started, actually, if that's all right by you, I am going to turn off the camera simply due to conserve on bandwidth to make sure that for those of you who have a slower connection can benefit from hopefully a better experience. So before we jump into Docker, Kubernetes, all those wonderful things, there's something I like to define over here that I think is important over here is what are microservices, right? Probably each and every one of us over here has a good idea as to what the heck is a microservice, but what's the difference, for example, between a microservice and a nanoservice? What's the difference between a microservice and what we might call a macro service? Where do we draw the line as to what a microservice is? How do we know that the code that we might have written does qualify as a microservice? Well, there's a couple of characteristics I'd like to propose for you guys when it comes to microservices. And to explore that, let me go to an authority over here, microservices.io. And I'll share that for you in the chat window. Microservices.io. Microservices, also known as the microservice architecture, is an architectural style that structures an application as a collection of services that are, and here are 5 characteristics I want to make sure that we recognize. The first 3 are architecture, the last 2 are organizational. So the first one, a microservice should be highly maintainable and testable. So for those of you who may be working with microservices over here, are they maintainable and testable? All right, how maintainable and testable are they? 2 very important characteristics. Do you have automated unit tests, integration tests, end-to-end tests for your microservices? Are they loosely coupled? Does service A require understanding of the inner working of service B? If that's the case, there's no loose coupling, there's a tight coupling between 2 services. So all service A should know is an endpoint and the structure of, say, service B. Not its inner working. Are they independently deployable? Very important over here. And I find a lot of architects miss that one over here. And that kind of falls into the previous one as well, loosely coupled. If they're tightly coupled, there is a good chance that they're no longer independently deployable, where it's much more difficult now to deploy service A independently of service B or vice versa. Now, the next one is hugely important. I'm going to say I see too many newcomers to the world of microservice forget about that one. It is organized around business capabilities. It is there to service business processes, not backend processes. All right, let's build them around the business, not around the technology. All right, very important over here. And if necessary, I can give you examples of that. And finally, it needs to be owned by a small, I'm going to say, DevOps team. If this is something that gets kicked around from maintainer to maintainer, it's not a microservice, right? There is one team that owns the microservice. That team is responsible for architecting, developing, testing, and deploying, and maintaining, operating that microservice. If they're not responsible for that, it is not owned by that team, which also implies that the team should be multidisciplinary. And we are getting into the idea of DevOps at this point. But my goal here is really to talk about well, not just microservices, but also containerization and a Kubernetes, Docker and Kubernetes. So what I'd like to do over here is throw in an example, an actual code example for you guys. Now, whether you're a programmer or not should not be a big deal. I am going to get hopefully not too technical, but throw some technicalities out there. And I'm going to use a Java Spring Boot application as a demo. But if you're a programmer, you use another stack, I think you'll be able to transfer those ideas to any other stack. And if you do have questions on other stacks, bring them up. I'll do my best to answer them. I'm not going to pretend I know every stack out there, but hey, I've had an experience with a number of them. So let me go to an actual project over here. Where is it? I'll go to my list of repository, and there is a project over here called Spring Boot Demo. It's actually public. There's nothing really exciting in here, but if you're interested, there it is in the chat window. And what I'd like to do over here is I'd like to start with that sample project. All right, now before I clone that project and start working at it, let me highlight roughly the mentality I'd like to consider when it comes to migrating to microservices. Start using containerization. And when it comes to that, something I'm going to mention is that moving to microservice architecture, moving to containerization, getting started with Kubernetes, I like to think it's not just a technological shift. And if you're going to remember just one thing out of this session, all right, is that moving to containerization, taking advantage of Kubernetes, all those wonderful things we're going to look at, remember that first and foremost, it's a cultural shift. We need to change the way we think about developing, packaging, deploying, and operating, monitoring our code. It is a cultural shift. Similar to the cultural shift we went through late 1990s, early 2000s, some of you might remember when virtualization became the norm. And I do remember distinctively thinking to myself, my goodness, virtualization is a terrible idea. It takes so much resource and so much more hassle. Why not just run why not just run application locally on server? We save so much effort, so much work over here. Just seemed like a much more natural way of doing things. But virtualization has made its proof. Most of us over here, I will assume, are aware, at least conceptually, of virtualization. And this is something today we take for granted. We don't even think about anymore. We just virtualize servers and services and whatever we want. We are at a similar point with containerization. And similar to virtualization and other similar disruptive technologies, we have to recognize that it's not just a matter of changing the technology, but maybe changing the culture, the way we think in our organization. And you'll see why as we carry along. And to illustrate that, let me walk us through a bit of a DevOps process over here, where we've got, well, there you go. Here's the scenario over here. We've got a development team, a DevOps team would be a better term over here. And on the other side, we've got our operation, our production environment over here, and with some application running over here. The structure of the production environment is not important. All right, so we want to send working code to our development environment. And to explore that as a scenario, let's begin with some kind of tracking system. I'm using Jira here as an example. Use whatever you want. This is actually an old presentation I've done a while back that I continue to use, but a request comes in. What is that request? Well, that request might be a request for new features, new capability for our application. Or it could be a bug request, all right, a bug fix request that comes in. There's a problem with the application, we need to fix it. It could be an emergency fix. It could be even as simple as fixing a typo on the presentation. It doesn't really matter. The process will be fundamentally one and the same. Now, there might be variant, but for now, we'll treat it as one and the same. So the development team over here receives that request. And ideally, as a DevOps team, self-organizing DevOps team, using maybe something like Scrum, they're going to organize themselves, decide, hey, we're going to work on this, who's going to work on this, and then the individual or individuals who will be working on that request will then go to their Git repository, their central code repository. Doesn't have to be Git, but they'll go to their central code repository and clone or pull the information locally. And I'll actually go through that step with you guys very soon. Right? Clone the information locally. They've got a copy of the code on their machine, and now they're all set to start working on that code. Cool, we're ready to rock and roll with that code. The developer over here, and when I'm using the word developer, I'm not treating the word developer as synonymous with programmer. A programmer is part of a development team. A tester is part of the development team. An architect is a developer. They're part of that development team. Even folks in operation who are part of the team that owns that microservice are also part of that dev team or DevOps team, if you prefer. So I do want to make it clear when I'm using the word dev over here, developer, I'm talking about somebody who is on the development team. Whether they're a programmer or not, that's moot. All right, and the team is multidisciplinary. So whoever has the necessary expertise, or the group that has the necessary expertise at this point, will start working on that code. Once the code works locally and we're able to push it, I do want to come back to that step. I'm glossing over a number of details that will be relevant for us later on. But once that code is good, we push it back to our repository, and here comes the pipeline. Whether you use Jenkins, you use Azure DevOps, you use Travis, you use TeamCity, you use whatever else, doesn't matter. There's a pipeline over here. We want to have a pipeline kick in. Why have a pipeline? Well, it doesn't have to be a pipeline, but it has to be an automated process that allows us to go through the build, verify, package, and deploy steps for our application. That's the important part for us over here, is that we want to automate those steps. And a pipelining tool is a natural tool, natural candidate to help us with that endeavor. So let's move ahead. The first thing a pipeline normally does is pull the code from the central repository and restore dependencies. For those of you coming from a Java background, we're talking Maven or Gradle. If you come from a .NET background, new build. If you come from a Node.js background, NPM. You come from a Python background, VM or pip or whatever you want to use. So pretty much all the modern development programming languages have a package management system of some kind. And even if you don't, you'll want to restore the dependencies. Normally, you don't want to store a binary file in your Git repository. Things like your jar files, your DLLs, and whatever else in here. Now, how do you restore those? I'm going to gloss over that from the internet, from a local repository. It doesn't really matter. Then what do we do? Well, we rebuild the full application. We do a full rebuild of the application. You'll notice I also threw some Docker in here. I'm mentioning Docker. We haven't talked about Docker yet, so I'll come back and explain why Docker is mentioned over here, but do a full rebuild, maybe with Docker, something I'll hint at as we carry along. And then we go through our massive battery of tests: unit tests, integration, system, security, UAT, UI, UX, end-to-end, or whatever type of test you want to throw in here. And those tests ideally are automated. But we're not here to talk about testing. We're here to talk about Docker and Kubernetes and a little bit of CI as we're talking about. Now we're about to cross the boundary between CI and CD, continuous integration. We've done our integration test, and at this point we should get a result back, black and white over here. Has the test passed or not? So test report gets sent back to the development team, the developers that were responsible for that, and then we using those reports either automatically or manually, we decide, do we move on to the next stage, which would be deployment, or do we hold off? All right, because there's a problem that we encountered, an unexpected problem that we encountered. Presuming that we choose to continue, that brings us to the next step: prepare the package. This is where we're going to create our formal jar, wars, exes, DLLs, zips, whatever we need over here for our application. We normally push those packages in a repository of some kind, a binary repository. I'm using Nexus as an example over here. It doesn't really matter. It could be Artifactory, it could be a cloud service, doesn't matter. So I pushed my package out there. It's version. Normally we do not erase previous version. We always increment a version. We use a timestamp. We use a counter and increment. We might use a hash, maybe our Git hash. It doesn't matter what we use, but we want to uniquely identify that deployable. And finally, we're ready to deploy. So what we do over here is using tools like Kubernetes, kubectl, we're going to indicate to the production environment, go ahead and pull that information over here, pull that information from the Nexus repository in production. And we'll talk about how that takes place as we carry along. But I just wanted to illustrate kind of sort of a bit of an idealized process when it comes to DevOps over here, when it comes to automating deployment, automating pretty much everything over here, eliminating the human element from repeatable tasks, automatable tasks, so that we human beings can focus on what computers cannot do, which is think, rationalize, draw informed conclusion, build wisdom. So things that computers are not able to do. Right? Why do what a computer can do when a computer, let's face it, is much cheaper than a human being when it comes to performing repetitive tasks? Or another way to think about this is that for all of us, our organization did not hire us to do the work of a computer. They've hired us to do things that computers cannot do. But that said, here's the rough process I'd like to explore with you guys across the next couple of hours. So this said, let's go back to the very beginning over here, where we're talking about a developer cloning the code and making changes to that code. I'd like to start exploring the development of that application. So looking at that stage in a little bit more detail. So back to the web browser. Where did we go? There we are. What I'm going to do over here is I'll copy the URL over here, my GitHub URL, and I'll open it in, let's say, let's do it in IntelliJ. You could do it in Eclipse, you could do it in whatever tool you want. It doesn't really matter. So I'm going to create a new project over here, and let's put that into, let's say, download. And wrong command. File new from version control. And here's my GitHub URL. And let's put that into, say, downloads Spring Boot demo to make it easier for me to delete afterwards. There we go. So step number one, as a member of the DevOps team, I need access to the code. So let's clone the repository. Now you'll see that the repository will not just be composed of Java code. Everything that I need to run that application will be visible, will be available from that one repository. Here's the code itself. Now, I don't want to turn this into a programming course, so I'm not going to worry too much about the structure of the application. I will switch to presentation mode. Boom, there we are. As quickly as it can come up. And a couple of quick things when it comes to the structure of that application. For those of you who are in the know, it is a Spring Boot application. It's not a very sophisticated Okay, sorry, I'm seeing some of you are saying that the screen is blank. It should not be blank. Can I confirm, can you guys see my screen? Working now? Okay, thank you very much for letting me know. Yes, can't see your screen. Sorry, I was just noticing those messages from earlier that I missed. Perfect, thanks for letting me know. Oh, I think it might have been when I started the slide where it was just a white page. So thanks for letting me know, I do appreciate it. All right, so what does this application do for us? Without getting into the code too much, there is a pom.xml, so it's a Maven application. I will run it as a Maven application. I'm actually going to run it raw for now. Let's crack open my Windows terminal. I'm going to do things from the command prompt. I don't want to shy away behind IDEs, behind wizards, that sort of thing. I'm just going to make sure I've got Maven. I may have it under my WSL. All right, and let's go into downloads, and that was Spring Boot demo, Maven. And we should be good. I'm getting a build failure because I haven't specified what I want to do. So I'm going to do a Spring Boot :run if I remember correctly. So this will compile my application, acquire the resources, and eventually fire off the application. That's what we're seeing over here. Just going to wait for it to finish booting. And there we go, should be up and running now. This is a web application, so I could treat it as a microservice application. It doesn't do much. The goal of this, again, it's not meant to be a programming course, but I'll go to localhost :8080, and I'm getting a white label error page, which is a good thing. All right, I know errors normally are not a good thing, but I'm getting fundamentally a 404, so that tells me, hey, the application is running, but there's nothing to display at this URL. I do believe I have a URL for the employees. Yeah, there it goes. So JSON payload that I can look at over here. There's another one over here called, I think it's called hello. And there we go. I get message null. Null. Why is it null? Well, the application has not been configured yet. That's okay. Let's talk about configuration. We are about to move into Dockers, Kubernetes, that sort of thing. So a big question that I often get asked, a good question I often get asked is, how do we deal with configuration in those environments? All right, I think we all understand the principle. I have different environment. I've got my, say, my dev environment. I have my test environment. I have my prod environment. All of those may have backing services like little databases over here, ideally micro database to accompany the service itself. And the URL for those databases, or connection string if you prefer, call it whatever you want, is going to vary from environment to environment. Things like the host name, maybe the port, username, password, or certificate, or whatever it is that we need to connect to those resources. So how do we deal with that? Well, the traditional approach that I'm assuming most of you are familiar with is a configuration file, which is still an option. All right, and there's nothing wrong with using configuration file, but I like to propose maybe more modern approach than using configuration file. The thing that I'm a little bit uncomfortable about configuration file, if I may go back to the presentation, come back. There we go. That we have over here. One of the things that we are doing over here is we are pushing an authoritative binary. So here's my authoritative binary over here that we probably built right here. All right, so I've built this authoritative binary over here, and I'm going to push it. All right, so we're going to run it through a battery of tests over here until we push it back to Nexus, which means that, well, potentially in dev, I may need to have a configuration file for my dev environment, configuration for my test environment, a configuration for my production environment. So the part that I'm a little bit uncomfortable with is that it implies I need to change the deployment unit, the package. If you want to think of it this way, if that configuration file is stored inside the jar files, the zip file, the exe or DLL, whatever I'm using over here, it means that I need to unzip the application, update the configuration file, rezip the application, and then deploy the application. I'm a bit uncomfortable by that because A, it adds complexity to my system. Working with modern system is already complex enough. Do we need to artificially add complexity? I'm of the opinion that the answer should be no. Second thing I'm a bit uncomfortable with is now I might have 3 versions of that application. All right, so I have a version for test, I have a version for dev, and I have a version for prod. That's funky. Not sure why it gave me a big line, but a version for prod. And the part that I'm not comfortable with over here is that if something goes wrong in prod, in test, in dev, is it because of the environment or is it because of the code? I'm sure we've all encountered that before, right? Where how many of you don't give me a show of hand if you want, but how many of you have encountered the following situation? You or somebody on your team develops a piece of code. They demonstrate it on their machine. It is wonderful, perfect, exactly what we need. So then we put it in production and nothing works. Does that sound familiar? I'll leave it as a rhetorical statement for now. All right. So I think most of us have been there. I know as a developer, I've been there too many times. And that's one of the reasons why, as much as possible, I would prefer to have one authoritative version of the binary. So that begs the question now, how the heck are we going to, provide configuration to the application itself? Well, the answer to that, it's not something I've made up. It's something that was popularized through the 12-factor. I don't know if you guys are familiar with that. I'll crack that open over here, 12factor.net. Put that in the chat window. I'm not going to go throughout all of the 12-factor over here, but these are factors, architectural considerations, if you prefer, when it comes to developing services, especially services that are meant to run in the cloud. But even if you're going to run them on-prem, I do believe that this continues to apply. So there's factors like one code base, tracked in revision control, many deployed. I started with that. All right, I have one code base stored in a Git repository, and I can deploy that code base in different environments. Actually, I haven't gone to that yet, but we'll get to that. Dependencies, I kind of hinted at that. Explicitly declare your dependencies. But now the third one, config, store configuration in the environment. What is that telling us? Well, I love this one over here. I think there's a lot of value behind it. Instead of storing things, configuration that are going to vary from environment to environment, how about we store them in environment variable as opposed to storing them in a file, as we would traditionally do, an XML file, a JSON file, YAML file, doesn't really matter. How about we use environment variable? What's the advantage of using environment variable? Well, before I talk about that, maybe I should take a step back. What the heck is an environment variable? An environment variable, most of you are probably familiar with that. But when it comes to environment variable, if I can demonstrate that over here, all operating system, Windows, Linux, Mac, that sort of thing, they all support environment variable, which are key value pair. So user equals JF Bilodeau. Home equals /home/JF Bilodeau. Name equals Galveza, etc. So these are examples of key value pair. They're available in the environment, right? When I start my shell, these environment variables are up. And I can add additional environment variable. For example, if I take a look at the list, I'll do an env and I'll grep message. Whoop, it doesn't exist. I can create that environment variable. And in Linux, you would use the export statement. It's not entirely necessary, but it'll be necessary for some of my later demo. So export message equals hello from environment. And there you go, I've created that environment variable over here. Applications running in that environment have access to those variables. They can read them. Java, .NET, Node, whatever, whatever stack you want to use, they're all capable of reading those from the environment, reading environment variables. So why use environment variable? Well, I can now inject configuration in our application without changing files. All right, so that's something that I like. I don't have to edit configuration file. Second thing I like about environment variable is that they're transient. They're ephemeral in the sense that right now, if I were to close my shell, you see over here that message equals hello is there. If I close my shell, reopen my shell, take a look at message, oh, it's gone. Why is that a good thing? Well, if I'm going to store sensitive information, all right, things like URLs to database, username, passwords, that sort of thing, I don't want to put them in a file. Many security experts will say putting those in a file is, or a stored password is fundamentally a compromised password. Not a good thing. All right. So what I want to do over here is I want to make sure that those settings are as ephemeral as possible. I see in the question window somebody is proposing things like secrets. All right, I'm assuming you're talking about secrets vault, that sort of thing. That's another great way to store things like your certificates, for example, X509 certificates. But you need a URL for those secrets, and you might need secrets to access those secrets. So when it comes to that, again, I would use an environment variable to provide the URL to our secret store. So that's another place where we would use environment variables to provide information that differs from environment to environment. So as a suggestion for you, if you're not already doing that, let's get into the habit, the mentality of using environment variable to store, to provide information that changes from environment to environment. If it doesn't change from environment to environment, then go ahead and use a file. Perfectly valid. That's what I would use myself. If there's a configuration that is, or a set of configuration that is universal, no matter what environment we run it in, then use a file. As long as you don't have to edit that file to deploy or manage that application, yeah, sure, use a configuration file, not a problem with that. But if you're going to store sensitive information or information that changes from environment to environment, consider using environment variable. Now, why are we discussing that? Well, let me go back to my application. So I'll go back to download Spring Boot demo. You've seen me run that application previously, and I'll rerun it right now. I've killed the application earlier by with that demo over here. And what I want to bring back to your attention over here is that page over here, localhost 8080/hello. First of all, is not up, should be up very soon. There it goes, should be up now. Does say message null. What is that message? Why am I getting null over here? Well, the reason is I haven't configured that environment. And this is something we'll say I want to change from environment to environment. The way that this is written in our code, let's go back to the application itself. In our code, if I may go back to my source, main, Java, and I think it's under the index controller. There we go. Here's my hello path. And you'll notice over here the message, I retrieve it from an environment variable, system.get environment variable, and I'm looking for an environment variable called app message. It's not set, and I can determine that it's not set over here. I'll stop the execution again. I'll do an env and grep app underscore message. It's not there. Let's change that. Export message equals and hello from environment. Oops, just like the exclamation mark. We'll get rid of that for now. So now I do have that app message. Whoops, I should have coded it as well. There it goes. So here's my message, hello from the environment. Let's rerun the application. Maven Spring Boot run. And coming up, should be up in just a moment. I'll hit refresh over here. Give it a second or two, and there we go. Now I can see I'm pulling the message from the environment variable. Right? So this is an example of using environment variable for our configuration. All right, so why am I showing you all of this? Some of you may be wondering at this point, thinking, JF, hey, I thought I was here to talk about containerization, Kubernetes, all those wonderful technology. Well, I wanted to lay out the scene for what we're going to discuss next. Why? Well, let's start with the fact that we have an application that is working. Looks good. Well, good is relative, of course, but we'll say for our discussion, it looks good. All right, hey, why not just put that in production as is? Well, there's a couple of things to consider. I hinted at one of those challenges previously, the situation where it works marvelously well on my machine, but if I put it in production, how do I know it's going to work exactly the same? Right? There's things like environment variables that I may need to carry over, or force the provider, force the environment to provide those environment variable. It doesn't really matter at this point. Another thing as well, this is a Spring Boot application, which implies that as a minimum, I need to run this on Java. Which version of Java? Java 8, Java 11, Java 14, 15. I never established that, did I? Do I need any external dependencies? Any additional jar files? anything in my environment, not just environment variables, but anything else in my environment over here. These are all things that I did not consider as of yet. As a programmer, I'm playing the role of a programmer right now. I set up my development environment to write and run Java code. But I need to bring this in prod. And that's where containerization is going to come into play. So how are we, or what is containerization? Well, let's review the evolution, what got us to where we are today when it comes to Docker, Kubernetes, those type of things. If I may go back a good number of years, all right, you don't have to date yourself. You can just say, no, JF, I've never encountered that in my career, but there was a time where mainframe was the default way to work with everything. And mainframe containerization is something that has been around for actually a really, really long time. But doing containers, especially in the way we use them today, has only been something that is available to, I'm going to say, the mere mortal for a short amount of time. But I can go back to even the 1980s over here, where we're talking about, for example, BSD jails, which is a form of containerization. Now, before I get into those, let's review kind of sort of what brought us to where we are today. Now, some of you might remember the days where we had a server, or a host, a server, forgive my terrible handwriting, and we ran a whole bunch of application on that server. There I go, here are all my application. And one reality when it comes to running just about any type of application, yesterday and today, and most likely tomorrow as well, is that application have dependencies. For example, that first application over here, application A, let's call it application A, B, and C. Application A may need, say, Java 8. Application B, good news, also needs Java 8. Application C, just to make it a little bit different, we'll say it needs .NET Core. 3, 4, doesn't really matter at this point, right? So we need to install those environments over here, those frameworks to be able to run our application. There might be other dependencies. And at this point, hey, everything is nice and rosy. Our 3 application runs side by side. They're not interfering with one another until our development comes up to us and says, hey, good news, we upgraded application B so that it uses Java 11. What do we do at this point? Do we remove Java 8 and install Java 11? So the application A and B now both run in Java 11. There's a good chance that it works, but for the sake of that discussion, what about if Java 11 or application A, for whatever reason, cannot run with Java 11? We need Java 8. So now the problem is we find ourselves running with 2 different version of Java on the same machine. And the same could happen with .NET and other environment as well. How do we deal with that? Well, we might set up additional servers or run it elsewhere, or figure out ways to isolate them from one another. So that would be a very antiquated problem by today's standard, because some of you are probably shaking your head thinking, Jeff, no, we don't run applications like that today. What we do is if we have multiple applications, we're going to have a server over here that is going to host those applications. So I've got application A, let's put in application B, and of course, application C. Over here, yes, they're going to need their own version of Java. So Java 8, Java 11, .NET, whatever, doesn't really matter. These are all the examples. And we are going to fully isolate them in their own virtual machine. Sounds familiar, at least I'm assuming. It sounds familiar to you guys, right? That's probably the way we are operating presently. So we have our own VMs over here. So there's my operating system for all of those with our dependencies. And today, that's pretty much a knee-jerk reaction. We don't even think about it anymore. We need to run a new application. We're not going to look for a VM. Oh, is there a VM where we could run that application? No, we're just going to spin up a new machine running Windows, Linux, whatever operating system you want to use. Doesn't matter. It's become the norm. And I like to think it's become the norm for good reason. All right, so that principle served us very well for decades. But we are finding ourselves moving away from virtualization. Now, it doesn't mean that virtualization is dead, it's a thing of the past. I don't think so. But virtualization, like any technology, is a trade-off, right? One advantage that we have with running things raw on a server over here is that resource usage. Resource usage is fairly low, as opposed to running it in virtualization, where resource usage can be higher because of that underlying operating system. There's less resource sharing, no resource sharing really between those over here. So it leads to heavier servers. Now, again, very often we're not going to think about it. RAM is cheap, disk is cheap, processing is cheap, that sort of thing. So we may not think about it. But one of the things I'm sure we're all cognizant of is capacity. All right, and again, I'll leave that as a rhetorical question, but how many of you are finding yourself in a situation where your organization is constantly struggling for capacity? Developers always release new code, they always release new capabilities, and to compound the problem, we're moving to the world of microservices, where each of those services fundamentally needs to run in their own isolated environment. And let's consider the fact that a service, go over here, a service is not just going to be a application. For example, my Spring Boot demo over here is not enough to qualify this as a microservice. This is not the full architecture of my microservice, right? So here's my Spring Boot demo. It exposes an endpoint on port 8080, as you've seen previously. Hypothetically, this is not the case for my sample code over here, but hypothetically, I might be using a background database over here. That database should be owned by the service. So so that's another architectural component of that service. The database is inseparable for the service, and the service is inseparable from the database. Another way to think about this is how much value is there behind a database if there's no way to work with the data. I like to think that if you have a database, but you cannot do anything with it, the value of that database is negative. You're paying for resources that do not provide value. If I have that code over here, my Spring Boot demo, but there's no backing database, how much value do I have behind it? Again, I like to think the value is 0. And we're not limiting ourselves to that, because to run my Spring Boot demo, what do I need? Well, I need Java, whatever version, let's say Java 11, doesn't really matter, right? I need Java to run that Spring Boot demo. Without Java, it doesn't run. Now, this is normally seen as a separate set of responsibility. The code is the responsibility. That's funky. The code is the responsibility of the dev team. Setting up the runtime environment is the responsibility of the operation team, system administrator. Database, responsibility of the DBA. But let's get out of that mindset. We are a team now. I'll actually erase all of that for now. The idea is this becomes my service as a whole. Actually, no, I'm missing some pieces in here. Because when we're going to put that into production, I don't want to just put in one instance out there. I'll probably want to push a load balancer at the front, proxy of some kind to distribute the load across multiple instances of my Spring Boot demo. I may also want to provide monitoring tool or monitoring capability over here to be able to monitor the health of my application over here. So my little microservice, which seems so simple from the get-go, architecting it requires a little bit more thought. It's not just thinking about, yeah, we're going to have a RESTful endpoint and we're going to talk to this database. There's a lot more to developing a microservice. And as I hinted at previously, it does require specialized knowledge. I'm not going to shy away from that. What I am going to move away from is the idea of silos. That's what I want to eliminate over here. That's a DevOps thing over here. Let's get rid of silo, where we have a silo for our databases, and a silo for our code, and a silo for our operation, and a silo for whatever else, monitoring and troubleshooting and whatever else. This is managed, developed, operated, and managed by a team. That would be the ideal that we should strive for. We may not be there already, but this would be what we should strive for ultimately. Okay, so our little microservice has become a little bit more complex. Developing the microservice implies that I need to have, well, the code plus Java, whatever version, plus the monitoring tool and whatever else I may need, plus a database in the backend, all those elements. I need to bring those up. In my testing environment, what do I need? Well, I need the code, compile. I need Java, whatever version. I need my monitoring tool, so a replication of the production environment, the backend database and services. I may have Kafka, for example. I may have Sparks. I may have other backing services over here that the application will need to use to fully simulate a production environment. And of course, the production environment, I need all of those as well. So one of the things that I'm hoping to establish over here before we get into our containerization demo is to understand that it's a bit silly. I'm not just going to say a bit silly. It is silly to treat those independently of one another. All right. The code over here, as we established previously, that code, my Spring Boot demo, it doesn't make sense to develop that code in isolation of the environment. How valuable from a business perspective is that code if I don't have an environment in which I can run it? And the opposite is also true. How valuable is a runtime production environment if there's no code to run it in? Serves no value. Delivers no ROI at this point. You've got this wonderful infrastructure, you've got all these wonderful capabilities, monitoring and backing up and IDS, IPS, and whatever else, yet there's no code running there. Are you delivering any value? No, not at all. Right? You need both. You need a operating environment and you need code to operate in that environment, whether it's code you wrote yourself or code you are going to develop yourself. It doesn't matter. So that's where containerization comes into play. If I can go back to kind of sort of our evolution over here, with containerization, we want to continue to take advantage of what we've discussed previously. We don't want to go back to what we've seen from the very beginning over here, where, okay, it's cool, it's easy to set up an application and run it side by side with other applications, but that gets messy very, very quickly. So we want to move towards virtualization, where using virtualization, I can run multiple machines side by side on the same hardware and isolate them from one another. I think that's a great thing. But there's some weight behind this, and typically additional operating requirement. So what I'd like to propose over here is, how about we repeat the same principle over here? I've got my application, let's say app A, app B, app C over here. Same framework. I'm going to say we need Java, whatever. We need Java, whatever. We need .NET, whatever. And isolate them. So virtualize them so they don't see each other. They don't interfere with one another. But let's get rid of the operating system below it. Have them talk directly to the underlying operating system. Let the kernel of your operating system do the isolation for you. So A, this provides lightweight virtualization. All right. What we are virtualizing now is an application and its environment instead of virtualizing a full machine and its operating system. So we're removing at least one big layer, the operating system layer, from our container. So we are getting into containerization over here. That's one advantage. But believe it or not, it's not the big advantage to containerization. I like to think it's a nice advantage. I get better ROI out of my infrastructure by being able to throw more application on the same hardware. So the physical hardware can now run more than what I could with my operating system. There's less weight behind it, but the real deal that makes containerization golden over here is the environment. A word that I've been using very loosely as of yet. But what I'm getting at over here is that application A and Java whatever, application B, Java whatever, application C, .NET whatever, instead of doing it the way we're accustomed to doing it with virtualization, where we create a new virtual machine, we install a base operating system, we install Java, .NET, Python, whatever we need, then we copy over the executable, do some configuration, hardening, bring it up, we're good to go. It's a very manual process. Now, I suspect most of us over here have mechanism to speed that up to make it more convenient for us, but it's still a very mechanical process. So what I'm going to suggest over here is, let's make this a more automated process, repeatable process, and portable process. And this is where technologies like Docker comes into play. I did mention that containerization is not new, and that's important over here. Docker did not invent containerization. However, it is certainly responsible for heavily popularizing containerization. Why is that? Why is it that even though containerization, depending on who you ask, was available since the 1980s, maybe even the 1960s, VAX VMS, for example, for those of you maybe in the know, if not, don't worry about it. So why is it that Docker popularized containerization, where prior to that, it was more of a fringe technology? Well, two reasons over here. They make containerization easy. And I think that's usually important over here. Second thing is that they make containers portable. And that's a huge deal over here that I'm going to emphasize as we carry along. So let's get started with the demos over here. Enough blah, blah. I'm setting up the foundation over here. Let's talk about what we need to know to make our to deal with containerization. Why am I excited about containerization? Why did I establish all those discussions with you guys? So let me go back to my Spring Boot application. The code is only part of the equation. The environment in which the code runs is the remaining part of that equation. And one of the things that is certainly a requirement over here is this application needs to run with Java. For example, right now I'm running Java version, I'm not sure, Java version 11 on my machine. Okay, cool. So that's what I'm running on my machine. That means that in test, I should be running Java 11, ideally the same version 9.1. And in dev, in prod, pardon me, I want to make sure I've got the same version of Java. So now let's start thinking in containers. The code by itself, useless. The environment by itself, useless. Only by combining the two do you get value. Why combine the two 3 times individually? One time in development, another time in our test environment, and a third time in production. And there may be more depending on the environment that you're working in. So what I'm going to do over here is I'm going to create a container. That container will contain everything that I need to run my Spring Boot application. Now, mine's pretty straightforward. It's only a Java application, but let's open up over here a file that I've created over here called a Docker file. Boom. There it is. So just to quickly highlight that file, I'm not going to spend a tremendous amount of time on it, but what I'm doing over here is I'm declaring here's how we're going to build and package the environment for that application in a container. The name of that file is Docker file. I mean, if I can crack it open over here, you'll see that it's Docker file. That's not a name that I've chosen. That's a standard Docker name over here. Docker file, capital D, lowercase f for file. That's the standard name that we use for a Docker file. What does that file do? Well, this is not a script. This is declarative. So for those of you who are familiar with things like Ansible, Chef, Puppet, SaltStack, that sort of thing, where we declaratively build an environment, same idea over here, but very, very simple DSL, domain-specific language. So first line, from OpenJDK:14-buster. What the heck is that? Well, I'm not going to build this container from a vacuum. I could build it from the ground up, as we might be accustomed to when building VMs. All right, when I create a VM, when I go to Hyper-V or VMware or whatever virtualization technology you want to use, and you click create a new VM, you got a blank environment. You're expected to provide your operating system, etc., to bring up that environment. Here, I could do the same, but that would be a waste of time and effort. Instead, I'm going to tell Docker over here, I want to create a runtime environment using OpenJDK. What the heck is OpenJDK? Well, to show you where it comes from, let me introduce you to another site, hub.docker.com, one of the largest repository on the internet. I'll put that in the chat window for you guys. Build and ship applications anywhere. Docker Hub is the world's easiest way to create, manage, and deliver your team's container application. This is the site from the company that develops Docker. Docker is developed by a commercial entity, Docker, but it is open source, so you don't have to pay the Docker Corporation anything to use Docker. It is open source. They do provide Docker services in here. And one of the things that they offer for free over here are we're going to call them images. And there's one over here called OpenJDK. So if I need to host a Java application, I'm going to use the OpenJDK Docker official image. So I don't have to manually install Java, manually configure this environment. And when it comes to that, this image is already built for me. So moving ahead, another example. Let me give you an example. Just the other day, I needed to run Postgres. The traditional way to run Postgres database or any database would be to download the installer, install it locally on the machine. But what I did instead is I just did a Postgres. I used a Postgres container, which is also a Docker official image over here. So it makes it very convenient for me to run my database server. So going back, for example, to my scenario over here where I need to run a database, well, instead of installing it manually and configuring it, why not use a container? That's something we can discuss in more detail. Moving ahead, other examples. I was talking about having to run a .NET application in a container. I need to package this over here. So let's take a look at .NET. I've got the .NET Framework, .NET Core, that sort of thing. This base image is not a Docker official image, but is provided right by Microsoft. All right from the horse's mouth over here. Microsoft creates and publishes their own container that we can use to run our .NET Core application. And there's other things that I can access over here. For example, let's say I need to run Oracle RDBMS. It's in here somewhere. I'm not seeing it. Or another example, if I could use a Microsoft example, last year I needed to do some work with SQL Server, Microsoft SQL Server. Guess what? It runs in a container as well. All right. So I love this capability over here because it allows me to run application in a container without having to install them locally. They're fully isolated from my system. I never needed to install anything on my system locally. Very easy to delete and clean. Nothing gets left behind. No crap gets left behind. And again, it's fully isolated from my system. So I know that running SQL Server on my machine will not interfere with other things, will not take over other things magically. And I'll demonstrate that as we carry along. So what I'm doing over here, let's go back to our code. First line is I'm telling Docker, okay, go ahead and grab the OpenJDK image from hub.docker.com or whatever registry I want to use. I don't have to use hub.docker.com. I could use alternative registry. Next, the rest is more housekeeping, if you want to call it that, setting up the environment. Go ahead and create a directory called OPT/OPT. It's a Linux container over here /OPT. That's going to be the working directory over here. So create it if it doesn't exist and cd into it. The comment that I have above really shows you what happens when I do a work dir OPT. It fundamentally calls make directory on that and cds into that directory. Following that, here's where a lot of the magic takes place. Go ahead and copy the jar file, the executable file that I've compiled over here into the container. And finally, notice how I'm setting up some environment variable. Actually, this one over here is kind of blue, so I'll remove it for now. But env app message greeting from container over here. That sounds familiar, doesn't it? That's the environment message that I've shown you earlier, that I set up earlier. So I'm going to provide a default for that environment variable. So when I go to /hello, the message will be greeting from container. And the last line over here sets up the default command to run when I fire up that container. Command java jar /opt/demo001 snapshot jar. So that tells Java, that tells the container, go ahead and run this jar file. Go ahead and run my Spring Boot application. So what does that look like? Well, let's look at it raw. What I'm going to do over here is I'll convert that into a container. Now, before I do the conversion, let's take a look at what containers I have installed locally. Actually, I may have to start my Docker service. I'll do that right now. I should do a sudo service Docker start. And there we go. And Docker images. And here I've got a series of images. And you can see in those images, I've got, for example, SQL Server. I was running that recently or last year, as I've mentioned. I guess I deleted my Postgres, but I was using Postgres not too long ago. I've got this HR system. I've got a MongoDB database. They're not actually running right now, but these are images that I've used. What I want to bring to your attention over here is I don't have Spring Boot demo as an image in here. Let me create it. All right, let me package my application in a container. How am I going to do that? Well, I'm going to use my Docker command, build, period. What does the period mean? Well, it means look for a Docker, I'll do an ls, look for a Docker file in the current directory. That's the Docker file that we have over here. Look for the Docker file in the current directory and build the Docker image from that. Let's go ahead and build that. Shouldn't take too long. So that, of course, is going to take its sweet time. Boom, we're done. All right, so that was actually, oops, fail stat, oh, sudo. No, I shouldn't have to sudo that. No such file or directory. Do I need to do a Maven build? Maybe it's because I haven't built the target. Maven, actually, let's take a look into target. What is it? Maven Spring Boot package. It's not package. Just sorry, I need to remind myself what the command is. Start, stop, build, repackage. Should do. That failed to be deployed. That's okay, but do I have now my well, sorry, I'm drawing a blank over here, or is it just jar? Not just package. Compilation failure, compile. I changed something. It's complaining about my index controller. I might have accidentally added, oh yeah, that explains it. Okay, so my apologies. I accidentally modified the code. That's why it was failing during compilation. So let's recompile this. Shouldn't take too long. Saying that, but of course it is taking its sweet time. And there we go. So if I take a look under my target directory, I should see, there you go. That's the file I was missing, demo 001 snapshot jar. That's the executable jar. I can show you that it is the executable jar. Let me do a java-jar demo, that's target, demo, whatever jar. So run it natively over here using the java jar command. So this is not in a container right now. I'm running it raw on my system. It's starting the Spring application. Let's go back to the web browser. There's my hello, refresh, and it shows up. I still has the hello from the environment in here, but I was able to successfully run it. Whoops, and I accidentally modified it again. I successfully ran it from the command line using the java jar target demo over here, the same command that we have over here, java jar, and here's the file I want to run. But now let's containerize it. I'm going to rerun over here my Docker build. Shouldn't take long. Oh, actually, sorry, there's one more parameter I want to pass over here. I want to tag my file. I'll call it Spring Boot Demo v1. Repository name must be lowercase. Yes, I do agree. Spring Boot Demo. Shouldn't take long. And now we should have a successful build. Boom, it took almost no time to create my container. You'll notice over here, it went through 5 steps. So step 1 of 5 from Open JDK 14 Buster. Now I already have this locally, so I did not have to download it from hub.docker.com, but fundamentally over here, it used the image, Open JDK image, that I hinted at previously. So there's my, whoops, that's not where I meant to go. There's my Open JDK image. You'll notice over here in the image, I am using a tag :14-buster. What does that mean? Well, here I'm using Open JDK version 14 running on Debian Buster. If you're not familiar with what Debian Buster is, don't sweat it too much. Debian Buster is a Linux operating system. It's the one that the vast majority of Linux operating systems are actually based on Ubuntu, Mint, and the other ones. You've got 2 big branches. You've got Buster or Debian, and you've got CentOS or Red Hat, as some of you might be familiar with. So that's what I'm doing over here. I'm saying go ahead and build an image based on JDK 14 running on Buster. Oh, but wait a minute. Debian Buster is an operating system. Did I not just say that one of the advantages of containerization is there is no virtualized operating system? So why are we talking about an operating system over here? Well, this is going to provide a Debian environment, not the Debian operating system. What's the difference over here? I can demonstrate that for you guys as we carry along, but I'm just going to mention it right now. I am not installing a Debian VM on my machine. I'm not running the Debian operating system on my machine. What I am doing over here is I'm requesting a Debian-like environment for this container. So nothing will get installed locally, nor will I be running an operating system, the Debian operating system, in that container. Later on, I'll demonstrate what I mean by that. But the container has been successfully created. So from Open JDK 14, that's going to be the base container that I'm going to use. So we have Java in that container, set up the OPT directory, copy the executable jar to that container, set up the environment variable, and finally set up the start command, Java jar, that sort of thing. Now I've built the image, but I'm not running it just yet. Let me show you. If I do a Docker images, now I see my Spring Boot demo that I've created 2 minutes ago. So I see over here that image has been created. It takes, oh, it's sizable. We'll come back to why it's that big, but it takes 685 megabytes. Actually, for those of you who are looking at all my size over here thinking, oh my God, that is huge, you're using up a lot of disk space. Yes and no. There's a lot of resource sharing happening behind the scenes that you may not realize just yet. But there's my Spring Boot demo. Now, it is not running. If I go back to my demo, refresh, spin, and eventually, whoop, this site is inaccessible. All right, not a problem. Let's start that container. If I was talking virtualization, I would say, let's boot the virtual machine, but there's no virtual machine over here. What I'm going to do over here is I'll run my Spring Boot application, but fully isolated from the rest of my system. Docker run Spring Boot demo. And whoops, did I do a typo? Spring Boot demo colon v1. And cannot find C group destination unknown. That's cute. Wait for container context cancel. That's a new one for me. My apologies. Docker run Spring Boot demo v1. Let me try another image over here. Docker run HR system, which is actually the same image that I did for another presentation. See what it says. No, there's something else happening. Let's try to sudo it. C group bound destination unknown. Be up and running. Yep. I'm gonna do a restart. And let's try that again. Okay. All right. Well, unfortunately, there's a little bit of troubleshooting I'll need to do, which is not a problem. It's about 12:20. I'm going to suggest, how about you guys have a bit of a break, walk around, refresh yourself. While you guys are enjoying a break, I'll get this up and running. I meant to take a break around that point anyway, so the timing is perfect, at least perfect for you guys. Sounds good? All right. Thank you very much for confirming. So moving ahead, right before the break, I wanted to run my Docker application, and I did get it up and running over here, just a little bit of tweaking to my environment. And this is a WSL Windows Services for Linux thing, but now it is up and running. So sudo docker, actually I could have removed the sudo altogether, but docker run Spring Boot demo v1 over here, and we can see the output. It is up and running, ready to accept HTTP requests. I did show you over here that the site was not accessible. So let me hit refresh and spin. The site is still inaccessible. What's going on? It is running. I see it over here. It's running, but I'm not getting a response. Well, I am running it in a container. So what's the difference over here? Well, the difference over here is that container is isolated from the rest of my system. Port 8080 is blocked from that container. So what I'll need to do over here is I'll stop the container. I'll just Control-C out over here. And instead, what I'll do over here is I'll add a command line parameter -p, and I'll say open up port 8080 and reroute it to port 8080 behind the scenes. So map port 8080 on my local machine to port 8080 on the container itself. So let's give that a quick go over here. I'll rerun the application. So pretty much the same command, except this time I am requesting a port to be open. Let's refresh. And boom, there we go. Greeting from container. So that container over here is up and running. I am able to send and receive HTTP requests to it. And I can see the message over here, greeting from container. Again, this is the message that comes from my environment variable that I provided in the Docker file. Now, this was meant to be a demo over here, storing an environment variable in the Docker file, so that makes the Docker image contain that environment variable as well. But remember what we said earlier, I want to use those environment variables to store information that is going to vary from environment to environment. Normally, I would not put that in my Docker file. Unless I wanted the same value across the board, I would not normally put it in my Docker file. But I can still override it. Let me change it without changing the container. So without changing a single byte of the original container image, let me change that message. I'll Control-C out once again, stop the application. There's different ways by which I could do that. Yeah, man. Thank you. And in here in my command prompt, I'm going to add a -e environment, and I'll change app, -e app message equal, and let's give it a different message over here, hello from command line. Oops, erase the S, and I want to make sure there's no typo. We're complaining as latest. There's something stuck in here. Whoops. Command line, Spring Boot demo v1. I don't like the fact that it shows me as latest over here. Oh, I see. There's an S. That's the rogue S that I dropped in by accident. Get rid of it. Boom. Run that. And there we are. All right, I see it's the S. Thank you very much for letting me know. There it is. My application is up and running. Refresh. Hello from command line. So I'm able to see my container now from the command line, or change the inner configuration of my container without changing one single byte, simply by injecting an environment variable in that container. All right. So we're starting to see over here what a container is. A container is an environment in which you run your application. And the idea over here is we can fusion the environment. So let's say I need to run JDK 11 on, or 14, I think in my case, on Debian Buster, the Debian Buster environment. And I'm able to inject parameters using environment variables without having to change configuration files. And run the application. It is portable. And I think that this is one of the big key feature over here of containerization. We hinted at that. It is portable. What does that mean? Well, here we go. I have my Spring Boot application running on my server. I've got another server. So this would be, let's say, my dev environment. Here's my test environment. And I want to run that same application. What I can do is I can push that container. Normally I would go through an intermediary, but push that container to another machine, push it to an intermediary registry, and then pull it from that machine, but I'll just bypass that for now. And this would bring in the application itself. App A in this case, and whatever I need to run the application. So Java code, the Java SDK plus Buster plus whatever else I may choose to add over here. So now I can move not just an executable, but the executable and all of its dependencies as well. I don't need to run installer. I don't need to change a single thing in the host environment, as long as the host has Docker up and running. The only caveat, though, is it needs to be the same flavor of operating system, Windows versus Linux. If my container over here is a Linux container, I need to run this on a Linux host. If it's a Windows container, I need to run it on a Windows host. But honestly, run it on Windows. Run it on, Linux. Nothing against Windows over here, but run your containers on Linux. You'll notice over here, I am running Windows, but I'm running them on WSL, Windows Services for Linux. WSL, if you're not familiar with that, this is a Microsoft product for Windows 10. It is free. You acquire it from the Microsoft Store, acquired online from the Microsoft Store, and it's for Windows 10. And it fundamentally allows you to run Linux side by side with Windows. Why did Microsoft create WSL? Well, one of the big use case for WSL, Windows Services for Linux, is to run Docker natively on Windows. Be able to run Linux Docker natively on Windows. So that's the reason over here why we have WSL. So this said, let's move ahead. I want to show you that I am working in an isolated environment. to do that, let me go back to my terminal over here, and actually I'll fire off a second terminal window. There we go. Switch to WSL, Windows Services for Linux. And what I'm going to do over here is I'm going to connect to that container over here. But I want to show you my environment a little bit. Right now, I am running Linux. I'm running LSB release. I'm running Ubuntu over here, Ubuntu Linux 8.4.5, side by side with Windows. I am running the Microsoft standard kernel over here. So this, again, this is a Microsoft product. That's not a third-party product over here. Microsoft standard WSL2 5472 compile on that day. That's cool. I'm also running the bash shell version, bash shell version 4420. You'll see why I'm showing you all that in a moment, but that's my local environment. Let me connect to my container over here. Similar to what you would do with a virtual machine, I can SSH or I can RDP into a virtual machine. I'm going to do the same, but I'll do it via Docker. I'll do a Docker exec and I'll say on Spring Boot demo to do v1. I should have tagged it because actually, let me see what the containers are running. Docker PS, because I'll need the container ID over here. So Docker exec in that container ID over here, that weird funky number that we have over here. And I'm going to say, I should have named it, but it automatically generates an identifier, so I'll use that and go ahead and execute bin bash. So the bash shell in that container. And whoops, it worked, but I forgot to tell Docker I want to run this interactively. IT over here, interactively, and connect the terminal. And exec. Oops, I need to put that before the container ID. And there you go. I'm in the container right now. So this would be kind of akin for me to connect to a VM using RDP, remote desktop protocol, or using SSH, or using whatever approach you might use over here. I'm in the container. If I take a look around, I can see my demo file over here. I can create files in here. Actually, I'll go to the root directory. There's the root directory. I'll create a quick file over here. I'll call it hello.txt. I'll even edit it. Oh, VI is not installed. That's funny. I thought I had VI installed. But I am in a container, not on my host machine. Actually, before I do that, let's take a look at this. Let's take a look at LSB release -a. Oop, command not found. Yet I was able to run it previously, right? Now I'm getting a command not found. Okay, well, let's see what kernel we're running. uname -a. That looks the same. It's the exact same kernel that I have up above. Not a coincidence over here. It is the same machine. The only thing is the host name has changed, but it is the exact same machine, the exact same kernel. I am not starting a different machine. What version of bash are we running? For bash-version, I'm running version 5.0.3. Here I was running for version 4420. So I am in a different environment over here. It is isolated from the rest of my machine. I can do things like apt install vim. I'm going to install vi over here. Whoops. Apt update. Let's download the updates. Shouldn't take long. And let's install vim. Yes. So the changes that I'm making to the quote unquote system are only being done in that container image. I'm not changing my system at all. All right, this is fully isolated. And to show you that, I'm going to go back to my home direct or my root directory. There's hello.txt, vim hello.txt, and I'm going to add some text over here. Hello from container. There we go. Save that. So there's the file hello.txt. Hello from container looks good. All right, let's exit out of the container. Exit. Brings me back to my host machine. Let's take a look at the root directory. Do you see the file hello.txt? And I'll leave that as a rhetorical question. It's not there. And that's important over here. Though I was able to make a change to the file system in the container, I do not see that change in my local machine. Containers run in isolation, even their file system run in isolation. Now, there's more I'd love to discuss when it comes to the file system, but we've only got a couple of hours together, so I'm going to put that aside for now. But be aware that the file system in a container is generally much more efficient than equivalent file system in virtual machine. Why? There's a number of good reasons for that. All right. When it comes to memory usage, there's also much more efficient memory usage in containers than what we have in virtual machine. And again, this is something we could discuss in more detail, but I'll leave it aside for now. But that is all secondary benefit to using container over here. Containers, the primary benefit is that level of portability and isolation that I'm showing you over here, where I can define that container once and run it anywhere I'd like. Anywhere that I have Docker, I can run that container. So now the mentality that we really need to develop is that if I'm going to move to containerized software, I want to recognize that now code and the runtime environment, they're no longer two separate things managed by two separate teams. They're now one and the same. We define the code and the runtime environment together, and we package it together in a container. Before we move ahead, I just want to catch up on a couple of questions over here. Is the session being recorded and can be reaccessed? Yes, it will be recorded, and you should get an email after this session giving you access to that recording. So that's one question over here. Another question, where it goes, is hello.txt still available if you restart a container? Good question. Yes and no. Yes, in the sense that if you choose to restart that exact same container, hello.txt is still there. No, in the sense that as a general best practice and a default in Kubernetes and Docker, when you restart a container, we start with a fresh instance every time. And this is by design over here. We want to make it so that if a container goes down because of the environment, we don't want to find ourselves in the situation where we cannot bring it back up because the environment is corrupt. So by default, every time I bring back up a container, I get a fresh slate. This said, for those of you who are thinking, well, what if I want to run something like a database, or I want to store log files? I want to be able to review those log files from that container. Well, what you want to take a look at is what we call Docker volumes, which allows you to do that in Docker, which allows you to provide persistent data that will persist across execution. But going back to your question, it's a great question. The short answer is yes, it can be if you choose to. Best practice, no. Let's make those files ephemeral. If we need to create a file, ensure that some files are not stored because I'm running a database, log loss, I should say, because I'm running a database, I'm running whatever else, then there are mechanisms like Docker volumes to help you achieve that. So good questions. But let me start to wind things down a little bit. All right, it's getting dangerously close to 1 o'clock. I do want to reserve plenty of time for questions, discussions as we carry along. So that's going to bring us to the last big piece I want to put in place. Let's go back to our whiteboard over here. And let's talk about our microservice that I hinted at over here. One, I don't want to call it erroneous assumption, but something that's easy to lose sight of is that a microservice ain't just a piece of code. It's a whole architecture. And that architecture will typically include things like load balancing, network discovery. So there might be things like DNS entries that we need to provide in our DNS server so that we can discover those services, at least discover the load balancer. Load balancer needs to be aware of those services. We need to be able to bring up and down those services as necessary, scale them out and scale them in, monitor them, upgrade them, update them when a new version comes out, being able to find back-end services like the database and other services that are running behind the scene. So there is a lot to a microservice architecture. If you are wondering, should I go to microservice architecture? If your thought is, I'd like to simplify my architecture, well, that's a bit of an oxymoron. Saying that I want a simple microservice architecture, it's a bit of an oxymoron. I'm not saying that a microservice architecture needs to be complex, but it's not the defining advantage of a microservice architecture. There's two important advantages to keep in mind. The first one is scalability. Well-designed microservice should be indefinitely scalable. And in terms of scalability, I hinted at the 12-factor application. There is one over here when it comes to concurrency, scale out via the process model. In other words, if your application is not meeting the demand, not meeting the capacity, don't throw more threads and more whatever at the application. Start additional instances. So scale out using the process model. Process meaning an application, a running application in this case. So that would be the preferred approach to scaling out our application. All right, so microservices, the second advantage, sorry, I don't think I mentioned that one, is agility. The ability to respond to changes faster, which is the prime reason why so many organizations are moving to microservice architecture. They recognize that change is the norm in our field. All right. I would ask the question, how many of you have ever participated in a development project where from beginning to end, no changes took place? I don't think many hands would go up if I were to ask you that question. So the reason why I'm mentioning this is I think we all recognize that change is the norm in our field. So how do we deal with that complexity, all those elements that I hinted at previously, all those concerns that we need to be aware of, things like scaling, load balancing, discovery, network path, network route for our package over here. What about recover or faults, recover from faults? What about monitoring of our architecture? Actually, I've already put discovery over here, a backend service, exposing our service, exposing our front-end services, routing. These are all concerns, and there's more that I'm sure we could come up with. And these are generic concerns. They're not even specific to the piece of code that I'm developing right now. Okay, so developing a microservice architecture has its advantages for sure, but it also has its caveats that we need to be aware of. So the question becomes, how do we manage that complexity? Not the development complexity, but the operating complexity. Well, the answer to that is simply Kubernetes, right? What is Kubernetes. We're finally getting into Kubernetes, and actually that was a question that was asked by some individuals. Is it possible to have a copy of the slide deck? You will get a copy of it. Actually, you should have received a copy of it by email. If not, you'll get one later on. But what I'd like to do over here is I'd like to get into Kubernetes over here. Whoops. Where is it? Should be in here somewhere. There we go. So Kubernetes, what is Kubernetes? Kubernetes is an open source system for automating deployment, scaling, and management of containerized application. So this is a layer above your containerized application, where with containers, you're working with applications and their environment. But it is a manual process when it comes to bringing them up, bringing them down, configuring them, and routing traffic between them, all those things that we hinted at previously. But it groups containers that makes up an application into logical unit for easy management and discovery. It is designed on the same principles that allows Google to run billions of containers a week. Kubernetes can scale without increasing your ops team. Why are they mentioning Google over here? Two reasons. The first reason is Google has the world's largest infrastructure. All right. So when it comes to that, no other company has an infrastructure the size of Google. There are other companies that have massive infrastructure close to Google, but Google remains the leader today. So Google over here runs billions of containers in a week. Google has one of the largest, most complex infrastructure out there. How do they manage that level of complexity? Well, there is not one software solution out there that worked for them. The scale that they're dealing with was beyond any solution, commercial or open source out there. So what did they do? They created their own. They called it 7 of 9 internally, named after a Star Trek character for the geeks amongst us. And when 7 of 9 became solid enough, what they did, actually, sorry, they called it Project 7, not 7 of 9, but Project 7. When it became mature enough, solid enough, they decided, hey, let's open source it. Let's give back to the community. And let's rename it to Kubernetes. And I think that's very relevant over here, because if it's good enough for Google, it's good enough for all of us. All right. If it can work with the scale of Google, it can work at any scale. So that's what Kubernetes is fundamentally about. It's a container orchestration solution. Whether testing locally or running on a global enterprise, Kubernetes flexibility grows with you to deliver your application consistently and easily, no matter how complex your needs are. And that's important for us as well. Kubernetes is open source, MIT license, so very liberal license, giving you the freedom to take advantage of on-premise, hybrid, or public cloud infrastructure, letting you effortlessly move workload to where it matters to you. And that's an important point over here. And this is a question that I get asked very often. I do a lot of cloud stuff, and I get asked a question, is there a way by which I can develop an application that will work in Azure and AWS and GCP and whatever else? Today, the answer to that is yes. You want to create an application and its infrastructure and run it wherever you like, go with Kubernetes. Containerization and Kubernetes, you will be able to run your application in all the major and many of the minor cloud vendors out there, DigitalOcean, Heroku, Rackspace, whatever else. They all support Kubernetes as well as first-class citizens. So this will allow you to run your application just about anywhere, and you're not limited to the cloud. If I wanted to run it on-prem, the option is there as well. All I need is a Kubernetes cluster on-prem, and I'm ready to rock and roll. So that's an important facet over here of Kubernetes. You can run it in the cloud, you can run it locally, you can run it hybrid, part in the cloud, part locally, and I can deploy the same Kubernetes recipes in any one of those environments with little to no change between them. Kubernetes can be deployed on bare metal cluster or on a cluster of virtual machine, however you want to set it up. But we are talking about working with a cluster. So cluster or container orchestration, that's really what Kubernetes is about, all right? The ability to define containers and how they fit together declaratively. And for that, let me start winding things down with maybe a quick Kubernetes demo over here. I'm not going to use my Spring Boot application. I'll use a different environment actually and introduce you to how I could go ahead and do some work with Kubernetes. One very convenient way to run Kubernetes is a product called Minikube. Actually, I should put that in the chat over here. For those of you who want to run Kubernetes locally, you want to play around with it, take a look at Minikube. Whoops, not Minikube. Cube, thank you. I still misspelled it, but there it is. It should bring me to install tool, and in here there should be Minikube on the Windows. I do believe that's where it's going to bring me. Actually, it's giving it to me raw, but I'll still give you the link to the Kubernetes installer. Here it is in the chat window. Boom. So let's go back to our VM. So what I'd like to do over here is actually, let me switch to root account. Not a best practice, but for now, I'll do that over here. Oops, I think I missed the password. Yes. And there we go. And now that I'm logged in as root, what I'll do for my convenience is let me just export and add user, was it local bin? And in here, cube, show you that it's installed. So that's what I'm going to run over here to provide a local Kubernetes cluster. So I do have Minikube available over here. Whoops, Minikube version. That full screen, Minikube version, and I'm running Minikube 131, which is a bit old, but it's going to be adequate for what I want to do. Let's start the Minikube cluster. This will take a minute or two. Could have started it before the presentation, but I wanted to do that live for you guys. So Minikube will download all the container that it needs. It's going to run within a container, take advantage of containerization, and bring up a Minikube, a Kubernetes cluster in a virtual machine. You can see over here it is using VirtualBox. If you're not familiar with VirtualBox, it's one of the leading desktop virtualization solution out there. It's open source, and that's what we're going to use to run our cluster. Shouldn't take too long, hopefully. While that's happening, if you guys have any questions, don't be shy. I'm almost disappointed. I'm not seeing a lot of questions coming up at this point, but that's quite all right. Setting up the VM. Can you speak more on treating logs as event stream and how that would look in a microservice architecture? So that's a good question. You're talking about treating logs as event stream. This is another 12-factor app over here. Logs, treat logs as event stream. The idea over here is instead of just writing your logs to file and then reviewing them periodically, monitoring them over here, let's run them through some kind of system. Apache Kafka is a good example of that. It doesn't have to be Kafka, but some kind of message streaming system. Whenever an application issues a log message, let's stream it through that. It's still okay to write it to a file. You could have a combination of both, write it to a file and stream it via a system over here and treat them as event stream. So those logs are not just there to troubleshoot your container or your application if something stops working, but they're there to give you awareness of what your application is doing right now. Right? They're a stream of event. They tell me what's happening right now with my application. Is that what you were asking about, Andre? Or does that answer your question? Actually, sorry, there was a second part over here. How would that look in a microservice architecture? In a microservice architecture, well, typically as part of my container over here, so this area would typically run in its own container over here. I might have a sidecar service, what we call a sidecar service over here, that receives the log and streams them to, let's say, Apache Kafka or some similar system over here, stream them out of the container. It could be the application itself or a sidecar service that streams them out, sends them to another endpoint. Another question comes up: does a microservice container require its own database running within? Generally, no, and I would not recommend that the database be part of that container. If I understand your question correctly, what you're asking over here is, should my microservice look like this in deployment? So I've got my microservice over here and I've got my little database. This would be okay if I'm using, let's say, an in-process database. Sure. But if it's not an in-process database, this is where I want to store my information, then the architecture should look as follows. I should have fundamentally two containers, one for the microservice, one for the database. So here's my application, here's the database. And the reason why you don't want to run the database in a microservice is that they need to be independent of one another. If the service goes down, we should not have to bring down the database. The service, its file system should be ephemeral. The database, the file system should be persistent. And we're going to use volumes, container volumes for that to ensure that the data is not lost. Different configuration. And also, more importantly, I want to be able to scale my microservice independently of the database. I want to have, let's say, 3 instances of my microservice, 1 instance or maybe 2 instances of the database itself, so I can scale them independently of one another. So does a microservice requires its own DB running? Ideally, a database, a microservice will have its own data store, but the data store is not part of the container of the service itself, unless you're dealing with an in-process database. Just to confirm, is that what you wanted to confirm? Hey, thank you very much for asking. That's a common question, and it's an important one for us. You guys are asking great questions. I really appreciate it. Let's go back to our VM over here. Oh, great. And I've lost my connection. I'll just wait for it to reconnect. Come on. There we go. We're back in. And I finished starting Minikube over here. Let's take a look at that together. Minikube status. And Minikube is running. I've got the what we call the kubeless service, the API service. I'm not going to get into those, but it is up and running. Another thing as well I'm going to start using is kubectl. Kubernetes control over here. So I've got Kubernetes installed, Kubernetes control running version 1.11 over here. That's good. Now, assuming that everything is set up, I should be able to do a kubectl cluster info. And there we go. I can see my cluster is running. Ooh, that's kind of hard to see over here. I'll select it so it's easier to see. Or how much work would it be to change that color? So I'm not as familiar with that terminal. There go, preferences and colors. And I'll use, there we go. That should be easier for us to read. There we go. So the cluster is up and running. I'm able to connect to it. Now, because this is running in a cluster inside containers, it is isolated, and that's important over here. The one way to look at it, let me go back to my whiteboard, wherever I put it, there we go, is that, there we go, we've got our Kubernetes, whoops, that's poorly drawn, but my Kubernetes cluster. K8S, which is a common abbreviation for Kubernetes cluster. So there's my Kubernetes cluster, and in here I've got different machines that are running. They're all running in isolation from the rest of the system. So outside the cluster, I don't have direct access to a machine. Instead, the cluster will expose an IP, one or more, that I can use, and using that IP will redirect traffic to whatever machine are responsible for those type of requests. To find out what is that IP, I'll do a mini cube IP, mini cube. It would help if I knew how to spell. And there it goes. So my IP is 192.168.99.100. That's how we would connect to it. And finally, here's actually something that a lot of people like about Minikube is its dashboard. I'll wait for it to come up, which will give you a nice web dashboard to see the health of your applications, of your cluster. And I'll just wait for that to come up. Should not take too long. Of course, I'm saying that's going to take its sweet time. Oh, and I've got a question over here. Should the ETL service be independent of database? As much as possible, yes, I do favor independence, and I do favor message streaming like Kafka, all right, when it comes to doing your loads of your data for your database, especially if you need to communicate events, communicate data from data source to data source, from service to service. I like to recommend make it as independent as possible from your database. I'm not saying you should make it a hard, fast rule to avoid dependency on a database, but as a general rule, yeah, keep it independent of your database. There you go. Whoops, failed to open the browser. That's okay. I should have my link over here. I'll try to open that over here. Firefox is coming up. And there's my Kubernetes dashboard over here. There's a lot I'd love to discuss with you guys, but we've only got a couple of minutes left together. There's a concept of namespaces. Think of them as application. For example, that architecture that I had drawn with you over somewhere here, that would probably run in its own namespace. Other things that we have, nodes, so the different machines on which Kubernetes is running. That's my cluster. There's only one right now, Minikube. Persistent volume for my database. There's none right now. Role, storage class, workload. I can look at those. There's a lot I could look at over here, but I'll leave it as that for now for my application. Instead, let's create a container. Let's run a container in the cluster over here. I'll use kubectl, and I'll create a new service. I'll run a new service called my web server, call it whatever you want, and I'll provide the following image. Image is going to be engine X. If you're not familiar with Nginx, it is today the world's most popular web server for a number of good reasons. And I'm going to say go ahead and run it on port 80. So this is going to fire off my first deployment to Kubernetes. Let's take a look at it over here. kubectl get pods, which would be kind of sort of a container. I'll leave it aside for now. There we go. Here's my web server that is running. Ready, whoops, 0 of 1. It's not actually running, but it will be running very soon. Let's take a look at the nodes or the pods over here. And I can see there go. Here's my web server. It is running, hasn't restarted. It's been around for 25 seconds. To see if it runs over here, the next thing I'm going to do is I'll try to connect to my web server over here on the IP address that I was given, which was where did I bring it up? Cube IP. There we go. Here's my IP address. Select that. Copy. Paste. Unable to connect. Oh, because I haven't set up the service, I bet you. But there's my web server over here. It is running in my cluster, but I have not connected it to the public IP address. So machines in the cluster have access to this IP address. There's the IP address to my application, 172.17.0.5. So Kubernetes created a virtual network, a private network over here that is used strictly by the containers. And containers, if they have the necessary path, can go to 172.17.0.5 and access that web server, that web server that I've created over here. Exposing the service, let's go ahead and do that. I'm going to expose my service. I'll use kubectl again. Expose the deployment. I called it my web server. Yeah, my web server over here. My web server. Type, don't worry about the type over here. There's a couple we could discuss, but I'll leave it as node port for now. Yes, I meant expose, not export. And web server expose. If everything goes well, refresh. And still not showing up over here. Let's take a look at the dashboard. There's my pod. And there it is. Where are my nodes? Not nodes, but services. I'm being blind. Or actually, I'll do that from the command line. I'm more accustomed to the command line. kubectl get service. Now, what's a service in Kubernetes? A service is fundamentally a microservice architecture. It could be a monolith as well, but that would be typically a service. There you go. Here's my cluster IP and node port. That would be the internal IP, and it's open actually on port 3311110. So I'll make a copy of that. Let's try that over here. There you go. Welcome to Nginx. I was able to connect to that service running in Kubernetes. I could next publish my web application. That would, well, it's on a different machine, so I would have to repeat some of the steps that I've shown you previously, but it would not be too difficult to do over here. We've seen over here how to open up that service. Another way by which I could have opened it, I could have done a kubectl service my web server and show me the URL kube service minikube. service, my web server. And there go, it gives me the full URL that I could have copied and pasted into Firefox or whatever web browser to see the service up and running. So that said, we're starting to see how Kubernetes is a container orchestration solution. It allows us to quickly and conveniently bring up not just one or two container, I mean, you can do that, but a whole architecture of containers in Kubernetes. Now, that's the role of Kubernetes, is to handle the complexity of running architecture, running microservice architecture, since as we established, a microservice architecture is not just one container. Typically, it will be a number of containers. You have your load balancer, the instances themselves, your backing services, your sidecar services, your persistence, and maybe your messaging services. All of that is what composes one microservice. So thanks to Kubernetes and using recipes, which I haven't gotten into, it makes it very convenient for me to run those services. Do you guys have any questions for me concerning what we've looked at so far? If not, what I'm going to do at this point is I'll start to wind down this presentation. I'm hoping that at this point, you guys have a deeper understanding as to what it is we're trying to achieve with containerization and Kubernetes. Unfortunately, 3 hours is not enough to really get you started with Kubernetes and Docker, but I'm hoping at this point we see why Docker is such a desirable component to add to our DevOps cycle, where now the code and the environment are one and the same. The code and the environment can easily be moved from machine to machine, be brought up and down conveniently, managing the configuration. Hopefully, the management will be a little bit more straightforward. And when it comes to Kubernetes, orchestrating all those services, providing paths between them, hiding them, encapsulating them behind our cluster over here. I see a couple of great questions that are coming up. How do you group component within a microservice in Kubernetes? That's where a pod comes in to play. In Kubernetes, let me go back to my diagram over here. If I have a service, my microservice, and I have a sidecar, if you're familiar with that design pattern, sidecar. Again, so, sorry for my terrible handwriting over here, sidecar. And both of those need to exist together and see each other. For example, talk to one another using localhost, which I would not be able to do across two containers. What I would do is I would put them together in a Kubernetes pod. So I did say that a pod is kind of sort of one container. I lied a little bit. A pod is actually a combination, a collection of containers. So going back to the question, how do we group component within a microservice in Kubernetes? If they need to run side by side on the same node, see one another, exchange information via Unix via localhost network, the loopback address, you put them together in the same pod. Are we able to create images with Kubernetes? No, if you want to get into that, if you're looking for a DevOps pipeline that works with Kubernetes, look at OpenShift, which is something that we also cover in our 2675, the course from which we're taking that curriculum from. So when it comes to that, you'll want to take a look at OpenShift. This will allow you to create images and push them to your container all in one go. So I'm hoping that this answers your question. If not, please bring them back with clarification, and I'll do my best to answer them for you guys. And I do thank you for your feedback over here. I'm seeing some comments, some feedback on the session, much appreciated. So what I'm going to do at this point, if you guys have further questions, scenarios you want to discuss, stick around. I'll be happy to discuss whatever may be of importance for you. If you got what you came to get in this session, well, hey, let's start winding things down. Now, before you leave the session today, there's one more thing I would appreciate if you could do for me. And that is the evaluation. The evaluation is done online. I'll put the link to the evaluation in the chat window. You can click on it. I'll bring you to the evaluation. That would be very appreciated if you could do that for me. There's another great question that came up. How does Kubernetes and Docker work together? Good question. And actually, to answer that one, let's modernize things a little bit because traditionally, you've got Docker, and you can see Kubernetes as being something on top of Docker that controls your images for you. That's a good way to think about it. But if you take a look at Kubernetes and Docker, let me do a quick Google search over here, Kubernetes, Docker. There is a good chance that one of the first thing that will come up is there go this great article, Don't Panic, Do Kubernetes and Docker. What are they talking about? Kubernetes is deprecating Docker as a container runtime. What does that mean? Well, what they're saying over here is that Docker was the containerization solution that was used by Kubernetes since the get-go, since day zero. Between the time that Kubernetes Docker came out, a new initiative, OCI, was set up, which stands for the Open Container Initiative. Which attempts to standardize how we interact with container, OCI. So what's happening over here is Kubernetes over here is deprecating Docker in favor of using OCI, Open Container Initiative. Open Container Initiative is fully implemented by Docker. Docker remains the #1 containerization solution out there. So what's happening over here is that instead of tying Kubernetes specifically to Docker so that Kubernetes can only run container in Docker, not alternative, there are a couple of alternatives out there, OCI is now what Kubernetes will use, so that if you choose to use a containerization technology other than Docker, you can. All right, so going back to your question over here, how does Kubernetes and Docker work together? I'm hoping that this helped answer the question and also modernize the answer to take into consideration OCI. Can you explain about Podman versus Docker? I remember someone was saying CentOS is not supporting Docker. It is only going to support Podman. Actually, I haven't heard that myself, but Podman is another containerization technology. It supports OCI, so that means that if I'm working with Kubernetes, it doesn't matter if I'm using Podman or if I'm using Docker itself. Kubernetes will talk OCI from that point forward, providing an abstraction layer between that. So when it comes to your question, I doubt that CentOS will drop support for Docker. I think what they're saying over here is that out of the box, CentOS will provide OCI, Open Container Initiative, through Podman before Docker. Other Docker container runtime is Linuxd. Yes, that's actually the very foundation that we can use to run with containerization. If I can add that maybe to the answer, Docker did not invent containerization. I've mentioned that previously, but something I should have added is that even the technologies that allows Docker to do what it's doing, provide an isolated file system, provide an isolated runtime environment, provide network path control, all those wonderful things. Docker did not even invent that technology. It uses the capabilities of the Linux kernel to do that. It just provided an environment, a package that makes it so convenient for us to create those container images and to spin them up, burn them down at our leisure. So hoping that this answers your question. You guys are asking a lot of great questions. I do appreciate it. If you have any other questions, don't be shy. As a reminder, I would really appreciate it if you could do the evaluation before leaving the session today. We do value your feedback. So if you have if you enjoyed the session, hey, please let us know. If there's something we could have done better next time, please let us know. We'll do our best to address that. So at this point, I'll stick around as long as necessary. Again, for those of you who got what you came to get, you're welcome to call it a day. Hope that you guys, well, I hope you guys have a fantastic weekend. Hope it's gorgeous wherever you are right now. It's a bit rainy where I am right now, but hopefully that's not a precursor to the weekend. But more importantly, I certainly hope that this will set you off on your journey towards containerization, understand what it's about. And I certainly hope you guys have as much fun and success with containers as I do at my end. HashiCorp also putting out Nomad as an alternative to Kubernetes. Yes, there are alternatives to Kubernetes, and thanks for sharing that one. And well, thank you very much. I do appreciate your feedback. Looking to the next seminar invite. Yeah, keep an eye out on our site at Web-Based Solutions. We have numerous free seminars coming out, free courses coming out. Take advantage of that. And I do apologize for sounding like a broken record, but I do hope you guys will take a moment to fill out the evaluation. Would you be sharing the recorded training? Yes, you will get that by email. Or you can keep an eye out on our site, but we will send you an email later on today, if not next week, probably next week at this point, with a link to the recording and the slides as well. Though the slides, actually, I'll put them over here that were provided as a URL. Let me give you the URL for that right now. Come on. Just a second, I'll get them for you. Oh, and I see somebody put them in the question window, but I'm having difficulty copying that. So I'll go to my email, and it was kindly sent to me yesterday. And where is it? There we go. Is that it? I'll put it in the chat window. Boom, there we go. So for those of you who want to download the file, there it is in the chat window. All right, another question. How do I size my infrastructure, hardware, number of servers, specs, etc.? That's a really, really good question. It's a bit of a tough one to answer. How many services are you looking at running? What are your services going to be doing? Are they going to be CPU bound, network bound, memory bound, disk bound, or whatever combination thereof over here? So the first thing you'll need to establish over here is what are we looking to run as a microservice? What are we looking to run in Kubernetes? How many machines are we going to run? What kind of machines are we going to need to run? What kind of network infrastructure will we need between them? Redundancy, that sort of thing. So it's a tough one to answer, but if you're looking at contrasting this with virtualization, typically you'll be able to run 5 to 10, maybe a dozen times as many containers as you might be able to run a virtual machine on a host. So maybe as a bit of a food for thought. So the service owner should provide the container sizing. Yes, I do agree with that. Let the service owner, whoever is developing that, determine what size would be preferable. All right, and yep, that's done. Thank you. You're quite welcome. All right, well, things are quiet at this point. I'm going to start winding down the session. If you have any questions, you've got just a couple more seconds. Otherwise, once again, hope everybody has a fantastic weekend. Thanks again for joining us, and hopefully we'll see you again in another seminar.